Hi, this is Subna. Today I am going to present about Trustzone system security by ARM. What is in Trustzone? As Trustzone is an security extension added to ARM processor, and ARM stands for Advanced Risk Machine. In early stage, it is called as Acron Risk Machine. RASC stands for Reduced Instruction Set. It is a type of an instruction set. An instruction set is a computer architecture that consists of related to programs, address modes, and registers and data. And there are major two types of instruction set. That is RASC and CASC. That is complex instruction set. RASC handles less than 100 instruction sets, and CAC handles more than 100 instruction sets. Mostly ARM uses 32 instruction set, and Trustzone technology is used to run a normal OS and a security OS within the same processor, and it allows the secure programs and data to be separated by the application, and it is programmed inside the hardware, so it is used to protect the memory and the peripherals. Memory means on-chip memory and off-chip memory. On-chip memory means the memory that are built within the processor itself, and off-chip memories are the memories that are built outside the chip, and on-chip memories are faster than the off-chip memory, since they are built within the processor itself. And since the secure program is programmed within the hardware itself, it will not affect the system performance, and it allows the hardware developers to develop security applications like DRM and web-based services. DRM stands for Digital Rights Management. It is an access control technology that is used to limit the digital contents on the device. It was designed by the hardware manufacturers and the individuals and distributors. And coming to the next is application modes. There are three types of application modes that are normal mode, system mode, monitor mode. In the normal mode, the user space applications are run, and in the system mode, the kernels runs or the system OS runs. The kernels means is the central module of OS that controls all the functions of OS, and in the monitor mode, the trusted kernel runs. That is the secure OS, and it also has monitor functions. It is used for content switching, and it is also used as an trusted gatekeeper. It is used to switch the devices that are common for the normal OS and the secure OS. And next is the Trustzone software. Trustzone software is used to provide minimum secure kernel, and its major function, other function, is to provide a driver that is act as an interface, act as an communicator between the normal OS and the secure OS. ARM provides an driver that is an SMC, that is secure monitor call. It is used as a driver between the normal OS and the secure OS. It prevents the normal OS to use the secure data that is available in the secure OS, and even though it prevents the attackers, and even though if the attackers have full access to the normal OS, he cannot access the secure OS. And the next one is the security levels. There are three levels of security, that is in client side, security in client side, and Trustzone software, and low level security feature. In low level security features, it is there are major three types, that is crypto accelerators, secure execution mode, and secure memory. In crypto accelerator is a co-processor that is used for encryption and decryption. It uses RSA and many other encryption decryption algorithm for encrypting the data and decrypting. And secure mode, secure execution mode, we uses firewalls, anti-malwares and anti-firewalls for protecting our system from attackers. And in secure memories, we use secure memories like flash, RAM and ROM for protecting and processing your data. And in the Trustzone software, it is a TE, that is trusted execution environment. We discuss it later. It is used for concentrate secure sensitive function and for leverage low level hardware security features and provide uniform interoperable standard based API. And in the security client side, it is the low level security feature, that is the runs in the normal OS. It is the less sensitive functions. It is the normal application that runs on the normal OS. And coming to next is the steps that are used for creating the TE, that is trusted execution environment. The first step, there are major three steps, that is first step is defining secure hardware architecture, implementing in silicon SoC, that is system on chip, and third step is combining SoC with the trusted OS. The first step is defining secure hardware architecture, that is in this we want to define what are the normal and the secure OS hardwares that are belonging to the normal and the secure OS. After defining what are the components that belonging to the normal OS and the secure OS, we want to divide them, and in the second step we want to implement the silicon on chip, that is after dividing the components, we want to combine them into a single chip, that is system on chip memory is an integrated circuit that is used to combine all the computer components into a single chip. And while combining, there are three major steps, that is monoprocessor configuration with the hardware firewall execution, and monoprocessor configuration with software firewall execution, and third one is the biprocessor configuration with the physical link. In this first, the monoprocessor configuration with the hardware firewall execution. In this, the two normal OS and the secure OS are separated using an hardware. The hardware must be an Trustzone hardware. Since it is used in hardware, it runs on both the normal and the secure OS runs on the same platform, and the normal is controlled by its separate OS, and the secure OS is controlled by the secure kernels. And in monoprocessor configuration software execution environment, it is the normal OS and the secure OS is divided using a software. Since it is divided using a software, as normal and both the normal world and the secure OS are controlled by a common OS, and it also has a same platform. And in the biprocessor configuration with the NFP link, both the normal world and the secure OS are separated, and they are communicated using a hardware. They are connected using physical link, and since they are in both different platforms, and they are controlled by different OS and security kernels. And after implementing the SoC, the third step is combining the SoC with the trusted OS, that is Trustzone ready program. like developing the software. There are some of the steps that are used for creating the software. The major steps are, first we want to gather the requirements that are used for for the creation of software based on their requirements. After collecting the requirements, they want to analyze what are the things that are needed for the developing the application. After that, SOC platform implementation gives the blueprints and the integration and the standards for the development of the applications. The blueprints are the designs and the structures that are given by the SOC platform implementation. And by using these blueprints, the software is created, and after that, the standards are also given for them, and based on that, the Trustzone ready program is created. After creating them, we need verification and validation. For this, the SOC platform assurance is given. In this, they provided the checklist that are used for checking whether the created program is robust or not. And after that, using those checklists, we identify whether the developed software is robust or not. And after that, it need to be certified, and for this it is given to an industry, certified industry like Netflix and a global platform. And after certification, only the Trustzone software is authorized. And at last, the Trustzone ready program is combined with the SOC, and as a result, TE is implemented, and it is ready for the use also. And the next is the ARM trusted based system architecture. It is basically divided on the blocks. It is an SOC, that is a combination of integrated components into a single chip. It consists of the major components that are available in the TE. The components are basically divided into 4 types that are based on trusted capabilities and high secure and switch capabilities, and has switch trusted capabilities. The blocks, some of the blocks coming under the trusted are physical DMC, region mapping, configuration register, and trusted test manufacturer, SCP, and some of the secure peripherals. And the blocks coming under has trusted WPs are processor cluster and core site debugger subsystem, and the switching capabilities are the input and output devices and its controllers. And the block coming under high secure regions are firmwares and DMC physical layer, and some of the components of configurable secure peripherals, and trusted region mapping, and flash controller. Basically, the structure is divided into 3 things, that is trusted execution environment, and security anchors, and system integrity. The core execution environment consists of trusted boot RAM and on-chip memory and off-chip memory. The on-chip memory is the trusted SRAM, that is a static RAM. It is used to store static data, and it can be it is a non-volatile memory. It is erased when the power is shut down. And the off-chip memory is the trusted RAM that is built outside the SOC, and it is also used as an static. It is also used for storing temporary data, and since it is an off-chip memory, and there is need of a physical connection between the device off-chip memory to the SOC, and the boot RAM is a device that is used to boot the workstation from the remote workstation or some other hostess, and the system integrity consists of debugging and test interface and power controller. Debugging is done by core side debug subsystem. It provides the debugging and traceable capabilities for the device, and test interface. This is done by the trusted test manufacturer. It provides the test case that are used for testing. Those are given by the manufacturers, and power control is done by the system control and power subsystem. Since different blocks requires different power source, different amount of power, those can be altered and given to those blocks by using this power subsystem. And the next is the system anchor. It consists of OTP, that is a one-time password, one-time program that is used for storing keys, key storage, and random number generation. It is used for storing that. It is used for generating random numbers that can be used for specific applications, and the time counters are used for counting times based on some intervals. And the SOC consists of three types of peripherals, that are non-secure peripherals and secure peripherals, and configurable secure peripherals. Non-secure peripherals are the devices that can be accessed both by the normal OS and the secure OS. And some of the peripherals are a timer, counter, and RTC and the MFHU. That are timer is a special clock device that is used to calculate the time interval, and the counter is a device that is used to count the number of times the processor or an event has been occurred. And RTC is a real-time clock that is used to calculate the real time. And coming to the secure peripherals, the secure peripherals are controlled by the trusted secure OS, and it consists of OTP, that is used for storing key storage, and random number generation, and real-time clock, and WD timer, that is used to maintain the world time. And the third one is the configurable peripherals. Configurable peripherals are those devices that are used to based upon the applications, or based upon the user specification. We can alter the functions of the peripherals. And the processor cluster consists of a processor L1 and L2, and GIC, that is general interrupt controller. General interrupt controller is an interrupt source that is it is used to support secure and non-secure interrupt sources. It prevents the normal world interrupt source that is to be modified, not to be modified for the secure OS. And L1 and L2 are the cache memory that are used by the processor, and processor is a device that is used for execution purpose. And the next one is the GPU, that is a graphical processing unit. It is also called as visual processing unit. It is used to alter the memory, to build an image, to form the frames so that it can be displayed as a video. It is used to see high definition videos in devices like phones, tablets, and computers and PCs. And the next block is switching capabilities. Under this we can there are two things, that is display controller and GPIO. That is display controller is a device that is used to control the display properties, and GPIO is the general purpose input output. It is used to control the hardware that are used for input and output. And next one is the flash memory. Flash memory is a non-volatile memory that is used for storing data temporarily, and this can be electrically erased and reused. And the firmware is a hardware program that is used for that is a combination of programs and memories and data. It is used for It is used for specific purpose, and DMC is a dynamic memory controller. It is used for efficient use of CPU and other devices and system IP. And the next one is the trusted configuration register. It is used by the TPM. It is a 20 byte digit. It can be used for configuring the software and the hardware. And the next one is the trusted region mapping. And trusted region mapping is a device that is used for mapping and control the flow of data inside the SOC. And next one is flash controller. Flash controller is a device that is used to control the activities of flash and other memory devices inside the SOC. Those are the things about system architecture. And the next one is the trusted platform security. And the main components of platform security are TE and TPM, that is trusted execution environment and trusted platform module. TE is not, both are not developed for replacing one another. TE acts as an safety wallet that prevents the data, whereas TPM acts as an lock for the TE, and both are required for the safety of the data. And coming to TE, that is a trusted execution environment. It is a device builder based on the requirement. It is built using Trustzone ready software and the combination of Trustzone technology hardware. And the main purpose of TE are protect and secure execution of a critical application in virtual environment. And the second one is safe and secure boot up, ensure of system software components that is in normal OS and secure OS. And the standard bodies that provides the TE are ARM, Trustzone, and Intel TXT, and AMD, and Mastron Visa, and global platform TE API. Since ARM and Trustzone API are developed, the security day by day the security reasons increases. ARM becomes needs and high security, so they form a partnership with the global platform, and they develop an TE, that is new TE, that is global platform TE API. And it consists of three aspects, that is TE client API specification, TE internal API specification, and TE system architecture. TE system architecture is the same architecture that is we seen before, and the TE internal API specification, it is a secure OS implementation, and it is enable us to port the software to the different vendors. And the next is TE client API specification. It is very similar to ARM Trustzone API, and it is used to run the application in run the application in normal OS, and those can be ported from the trusted Trustzone API to the client API without using any wrappings. And next one is the Trustzone platform modules. The Trustzone platform module, the main use of Trustzone platform module is remote attention and binding and sealing. In remote attention, while we are using different client-side applications and using hardware, we need to ensure that the software or the applications and hardware should be robust. To verify we are using TPM, and this is used to verify both the software and the hardware that is robust. And the next one is the binding. For this we use an RAC algorithm. This can be used, it is implemented in the on chip, so that every data entering into the chip can be encrypted using any RSA algorithm, and so that the data is secured and cannot be accessed by outside environment. And the sealing, it is used to protect ensure that the data cannot be accessed and it cannot be encrypted. In sealing mode, the application from the normal OS cannot access the application data in the secure OS. And the next is GP compliance and certifications. This consists of two things, that is Global Platform Device Committee and certification work group. The Global Platform Device Committee is responsible for publishing and reviewing what are the commands that are about the published devices, and they research on this new and publish the new technologies. And the certification work group is responsible for certification and checking. They provide the checklist for certifying the device and verifying at chip level, and they define the security targets. And the global platform demands are content based on cloud based, used for content switching and in payments like bank, online transactions and other transactions, and in enterprise like anti-malwares and antivirus and firewall executions, and in commerce like vouchers, local based services and some other things. Recently, Trustzone technology is used in Google Wallet for secure online transactions, and it is also implemented in Samsung S3 mobile devices. And how it works means, while giving input, those inputs are transferred to the on chip, and there it is using the RSA algorithm to, and those data can be encrypted and given to the about ARM, that is ARM processor with the secure execution, and after that it is transferred to the secure boot, and from there it is transferred to the upper layer, that is Trustzone. Trustzone is a device that is used to collect the trusted data and trusted inputs. From there it is again transmitted to the service provider. From there, once the data is verified, the service is provided to the user. And next is the Trustzone technology is implemented in Android, that is MobiCore. And MobiCore is a secure OS designed for ARM Trustzone technology, and this prevents the normal OS, separate the normal OS and the isolated execution environment, that is the secure OS. And for implementing Trustzone in Android, we are using some of the components like QEMU, hypervisor, and L4 runtime, and L4 Android. Fiasco microkernel. QEMU. It is a quick emulator. An emulator is a hardware or software or combination of both that is used to duplicate a single system. And a quick emulator uses dynamic binary translator that is used to port the things to the different CPU architecture based on the application. And next is the hypervisor. The hypervisor is a device that acts as a communication between the QEMU and the normal OS and the secure OS. Since it is used for content switching, it prevents the data enter from the normal OS to the secure OS. and it is also used as an robust gatekeeper for preventing the for use and defense which OS need to communicate with the common device like displays and IO devices. And the next one is the Fiasco microkernel. It provides a software that is used to implement the application within the environment, and this is the only software that runs in the secure OS, and this provides a minimum security. And next one is the L4 runtime. L4 stands for second generation kernels, and L4 runtime it provides a set of interface and libraries that are used to build applications, and if it is a low performance components, it provides a direct link to the microkernel. And the next one is the L4 Android, and L4 Android is derived from L4 Linux, and it provides a layer of OS for running applications on it, and it is implemented in Android versions 2.2 and 2.3, and that's all the thing about Android. And the main advantages of using Trustzone are quicker to market with the right product, and reduce cost, and increase sales, and provide standard API for security software and hardware security. And that's all the things about Trustzone, and thank you.